All right, questions on yesterday's assignment, Elite?
15.
15? All right, 15. Make sure everybody's paying attention, please. All right. Find the point on the graph of the function that is closest to the given point. So, f of x equals the square root of x, and my point is 4, 0. Did you get started on it?
Yeah.
All right, what'd you do first?
Well, primary function would be the distance formula.
All right, so I've got x minus 4 squared plus y squared.
Right.
Okay.
And then you plug in the y, because what's the square root of x?
All right, so x squared minus 8x plus 16 plus x.
Okay, that's where I messed up.
Do I need to keep going?
Yes.
All right, now what? Just the derivative of the inside. I only need the derivative of the inside, so that's 2x minus 7. So equal to 0, so I get x equals 7 halves. Then what?
You plug that back in to square root of that.
So plug that back in.
You get like 1.871.
So my point is 7 halves, square root of 7 halves. Raise your hand, please. What do I know about this point? Abby?
On the graph of f equals the square root of x, that's the point that's going to be closest to 4, 0.
Perfect, thank you.
So, would you make it as a decimal?
Yeah.
Like, we plug 3.5 in and actually got a decimal.
That's fine. Anything else on those 5? Natalie?
So when you get your x value, do you plug it into your primary equation?
Secondary. If you've got x and you want the other variable, you plug it into your secondary. Yes.
Like infinite. You just call
All right, anything else on those 5? All right, I've got, I think, 3 more examples I want to hit, and then we'll do 5 more problems to work on. So back on page 262, I want to start with number 20. So 262, I want to look at number 20. And we'll wait till those two get back. 263, sorry. Sorry.
I thought I did.
Oh, yeah, we did 20.
We already did 20.
We did 20?
Yeah.
That's right. All right, so I want to do 22 then. 22 is the next one I want to do. Well, where was he letting him in from? I figured it was just downstairs.
They probably got
Don't
lost.
ask me.
Or maybe Jarrell stuck
Probably Jarrell stood down and got himself one.
And they both walked out. Oh, that'd be so funny.
Yeah, they called me. I said, you didn't. I'm gonna lock myself out. Right. I'm gonna lock myself out.
One time I was walking.
I tried to tell my mom.
Sounds like they opened the door.
I need to tell her that. Oh, my sister listened.
Oh.
Really?
Because I called one of us.
Someone grabbed the door so he didn't like hold the hand.
We like this.
That's what we do with you, October.
Okay, Brady, I don't really appreciate your attitude this week with me. I don't know what I did, but I'm not appreciating it. What?
Do I get lost?
No, I didn't let me in, so I had to go all the way around.
Yeah, what did y'all say about me?
You can listen to it on the.
Oh, yes.
Yeah, you did.
It was all Malroy.
Mallard K?
Call me by my middle name.
I may have come up with the idea.
All right, 22. 22 says we have a rectangle that is bounded by the x and y axes and the graph of y equals 6 minus x over 2. Okay. What length and width should the rectangle be so that its area is a maximum? All right, so talk to me about it.
So would the equation given be the secondary?
The equation given is going to be the secondary.
So you always have a y value, y equals is going to be secondary?
That's correct. Good observation.
All
right, what else?
Area is your primary.
Area is going to be my primary. In this case, instead of length and width, what should I use? X and Y. All right, and then what?
Yes, that's solved for one.
It's already solved for. So I plug it in. Okay, like we did yesterday, I'm going to take that 1/2 out. Gives me 6x minus x squared. Take the derivative. So 1/2, that's going to be 6 minus 2x. Set it equal to 0. So I end up with x equals 3. Plug it back in. So 6 minus 3, 3. So I get 3/2. So what do 3 and 3/2 represent? The length and width of the rectangle. So the rectangle is going to be 3 wide, or 1.5 tall, and that's going to produce the greatest area. The rectangle with the greatest area that's trapped in that little reef. Questions on that one? Alright, then I want to look at example 4. Where are you, example 4? And again, there you are. And again, just look at the prompt, don't look at what they did. Alright. So example 4 says 2 posts, one 12 feet high, the other one 28 feet high, and they stand 30 feet apart. And they are to be stayed by 2 wires. What does it mean to be stayed by 2 wires? What? Yeah, pretty much supported is what they mean. Okay, to keep them in place. All right. Does anybody know what those wires are called? They actually have a name.
Barbed wire.
No, we did it back in pre-calc. We talked about the name of it back in pre-calc. They're called guy wires. Okay, so those poles, you know, the electric poles, and then you see those wires coming down. They go to the ground from electric poles. Those wires are called guy wires.
What are they holding on to the ground, though?
I don't think they're run into the ground. Yeah. So that's what those are. That's free for today. Attached to a single stake running from ground level to the top of each post. Where should the stake be placed to use the least amount of wire? So I've got wire here, I've got wire there, and somewhere in between I want to put a stake, and I want to make the amount of wire as small as the amount of wire I use as small as possible. All right. So talk to me. Turn the page so you're not cheating. And talk to me about this problem. Roshan?
Would you use Pythagorean theorem?
Okay.
Try and get the smallest hypotenuse possible.
All right. That's going to the Pythagorean theorem is going to come into play for sure.
Would you label the hypotenuse as x and y?
All right. So let's label this x and y.
What you have to do, like,
And then we do x plus y equals z.
X plus y. Well, what is x? What do these two things represent?
The wire.
Wires. So let's make this equal to w. Very good.
what you have to, like,
Okay.
set up a proportion to, like, figure out the size or something.
We're probably going to be closer to what Roshan said, and that is Pythagorean theorem. Pythagorean theorem is going to come into play somewhere. All right. Now what? Well, we already know it's our primary. Why do we know it's our primary? What are we trying to do? What's our goal?
Find the wire.
Find the minimum amount of wire. Okay? So there's my wire, so that means this is my primary because I want a minimum amount of wire. So we need a secondary, that's correct. What? Pythagorean theorem is going to be our secondary. So talk to me about that. Ethan, what do you got?
You separate the two,
Separate the two.
bottom, so it'd be like x and then 30.
So I for sure have x squared equals 12 squared plus.
Make that like z then.
All right, make that z. So this makes it z squared.
You
Okay.
can make that other side like 30 minus z.
All right, so the other side I'm gonna have y squared equals 28 squared, and then Ethan said plus 30 minus z squared. Everybody good with 30 minus z?
Yeah.
I like it. You guys are doing good so far.
Solve for a variable.
Yeah,
Solve for a variable and plug in. What am I going to solve for?
Y. Or X is
You're close. We actually want to solve for x here, and we want to solve for y here. We actually want to solve for both of these. And substitute them, and then what's my only variable going to be left?
The Z.
Z. Because both of these, what do both of these have in common?
A Z.
They both have a z. So I want to solve for both of these and then plug them in. Okay, so to solve for x, all I have to do is what? Square root. So that's 144 plus z squared. All right, and the other one, take the square root. Somebody's going to have to help me with 28 squared. It's less than 900. I know that much.
25 is 6.5.
Well, somebody's got a calculator, right? How much? 784. And let's go ahead and multiply that out. That's going to be 900 minus 60z plus z squared. All right, so 1684 minus 60z plus z squared.
You find the derivative of each thing on the radical? The odds of what do I do with my pen?
The smartboard one?
When you find the derivative of both on the radical?
Actually, at this time, the radical is going to have to stay since they're separate. Okay, remember what's the easy way to take the derivative of a radical? A square root. What?
Like make that parentheses.
Yeah, there's a quicker way than that.
1 over 2 the radical.
1 over 2 times the radical, and then the derivative of the inside of the radical goes on top. So, derivative of the inside of the radical is 2z, and then 2 times the radical down here on the bottom.
Sure.
All right, plus negative 60 plus 2z over 2 times the radical. What are you confused about?
I don't know.
Talk to me.
I don't know what I'm confused about. I just got lost.
Is that 12? What is that? What is that?
Yes. All right, I'm gonna go ahead and cancel these 2's. Okay, and same thing up here, cancel those. So that's gone, and this is actually negative 30, and that's gone.
So I have a question.
and those 2's are gone.
Okay, simple algebra question. Whenever you're simplifying the bottom, you can't just simplify like the 2 and the 2. If you're gonna simplify the bottom and the top, you have to do it by the whole thing, right?
Correct.
I thought after we take the derivative, we have to set it equal to 0.
We're going to eventually. We'll probably do that on the next step.
Okay.
All right, so I'm gonna set it equal to 0, and I'm gonna go ahead and take the denominator on the right to the top left, denominator on the left to the top right. So that's going to be z square root 1684 minus 60z plus z squared, and then plus negative 30 plus z times that square root. Is that plus z squared? Yeah.
On a scale of 1 to 10, will it all this calculate and or test?
This is probably a little bit too involved.
Thank you. I would a lot bit too involved. Do you think it's possible to be on the AP test?
That's probably a little bit too involved for the AP test.
Oh, shit.
All right. Now, at this point, we're going to use our calculator. So somebody's got their calculator. Let's go ahead and graph that. And what is it I'm looking for?
Minimum.
No. What do I have this set equal to? Where it equals 0. So I'm interested where the graph of this does what? Equals 0, which means it's going to do what? Touch the x-axis. All right, so somebody graph that. Give me my x-axis spots. And what are the limits of z? Somebody tell me what are the limits of z? What are my domain limits on z?
Could be
12 to 28.
Nope.
I don't know. I was thinking too.
Look at the figure.
Is it 1 to 30?
0 to 30.
0 to 30.
Less than 30.
Well, I thought you can't have a stake at 0.
Why not?
That's where the pole is.
It's probably not going to happen, but I could have one there. I could bring my wire straight down and then over. Probably not going to happen, but it can happen. So I could go straight down here and then all the way across, or I could go straight down here and all the way across. So those are possibilities. Anybody got it yet?
No, I was listening to you.
And actually, we probably just should have stopped right here, put that baby in the calculator, and found our zeros.
Would it be 9 and
I like 9, but I want the actual numbers. Menu, analyze graph, 0. Menu, analyze graph, 0. I'm pretty sure one of them is 9.
0?
Menu, analyze graph, 0. Click on the left, click on the right, and then it'll tell you what it is.
Oh my god. I don't know what I'm doing.
No, it's a lot.
9 is 1?
Yeah.
Yeah?
Abby?
Oh, I just have a question about my calculator.
Yes?
The last 9 times I've tried to graph something, the graph never shows up.
And we probably need to change your window. Does it ever touch again? You guys get to touch again?
Well, it means that like the
What does it say?
negative 22.5.
Negative 22.5? Alright, so we don't want that. You're right. So it's not in our domain. So that means 9 is what we want. Now, this problem is different than our other problems because we actually were able to set a lower limit and we are actually able to set an upper limit. Okay? So that means I actually have an interval. If I have an interval, what type of maximum or minimum am I interested in? What? absolute. So if I'm interested in absolute, what do I have to check? The endpoints and my critical point. So I need to check them all to see which one's the smallest. Okay? So we've got our 9. We also need to check 0, and we also want to check 30. Okay? So where am I going to plug that in? I would say right here. Because that's where W is, and it's in terms of Z. Okay? So somebody with a calculator, plug these 3 values in there for me. 0 should be pretty easy. 0 is going to be 12, and whatever this plus is whatever the square root of 1684 is.
So you're plugging in our endpoints because it's an absolute?
Because we actually have a defined interval. On our other problems, like the other ones were 2 positive numbers. I don't have a defined interval. There's just a ton of positive numbers. So whatever I find has to be my answer. But in this case, what Z is limited. So if Z is limited, or whatever we're trying to find is limited, we need to check the endpoints as well as what I got. 9 is 50. Okay. Anybody get 0 yet? 53. And anybody get 30 yet? What is it? What did you say? Is there any decimals? 3 decimals. Were there any decimals on 53? 53.036. Remember, anytime I give an answer and decimals show up, how many decimals do I want? 3. Make sure you give me 3. So, where does my stake need to be in order to have the least amount of wire?
So 9.
It needs to be at 9 because 9 produces a length of 50. The other 2 are 53.036 and 60.311. So if I want the shortest amount of wire from here to there and then there to there, this distance right here has to be 9. And is that what the problem asks?
Yeah.
Is that what it want me to find? There it is. Okay? And again, I should have saved some time and just plugged this right in here and found the zeros there. We should have done that. All right, any other questions on this? All right, let me put your next 5 up there. I hope your head wasn't blocking this over here.
I had pretty big.
All right, so we stopped at 15 yesterday. So I want 17, 19, 21, 25, and 29. Those are the 5 I want us working on today.